On to example 5. We're deriving sine cubed of cosine squared of 2x. So this is going to work very much similar to the last several examples where we have to use the chain rule multiple times in order to solve this problem. But first what we need to do is convert some of our notation. This sine cubed needs to turn into a sine of everything to the third power. Same thing with the cosine squared. So we're just going to need to convert this a little bit first. So we have d dx of big set of parentheses sine of everything on the inside all to the third power. So I just took that third on the sine and I moved it out to the back, just so it's clear what we're doing and what we mean by sine to the third. Let's do the same thing with this squared as well. So I'm still not deriving, so I have to carry this lovely d dx thing along. I haven't derived anything. So I'm going to have the sine to the third as before, and then I'm going to take this cosine squared, I'm going to turn that into a power on cosine. So we have cosine of 2x squared. Okay? Because the cosine was squared, everything regarding that cosine is now squared. Okay. So we just converted all of our powers on the trig functions to powers on everything. So now we need to figure out how to derive this. What is the outermost function? What is the biggest thing that is happening here? Turns out it's the cube. That's what's happening first and foremost. It's the outermost function. And then the inside of that is going to be the sine. And then the inside of that is going to be a squared. So this is going to get complicated real fast, as you can tell. Inside of that is a squared. Inside of that is going to be, okay, I'm running out of colors. It's going to be a cosine. And then the inside of that is going to be this 2x. So we have lots of things being composed here. We have 5 functions, I believe, if I can count. Yes, so we have 5 things being composed. So this is going to get messy. Hopefully we can keep our work straight. So the first thing we want to do is derive the blue stuff. So we derive the 3 part here. We bring that down in front, copy paste everything just as we did before. So we have 3 times sine of all this loveliness. Make sure you get your parentheses right, because that's very easy to mess up. All right, so we derived just the outside part. Everything else was just copy pasted from the inside. Okay? Now we need to derive the inside of this thing. So the sine of all this loveliness. So the outside function of the green underlined bit is going to just be cosine. So you have cosine of everything that's inside that function. So you have cosine of cosine 2x squared. Okay? Because all we did was derive the sine. Now we need to derive the inside of that thing, which is going to be this squared function. So let's see here, what color did I use for that? Purple. So we have, this is going to be our next thing that we need to derive. This thing. Okay? It's good to sequentially do this. Don't try to do it from the very beginning, like underline as you derive. It's usually helpful to do it that way. Derive the purple underline thing on the right. So we have to multiply by the derivative of that. So it'd be times 2, because we're just bringing this 2 down in front. That's all we're doing. Times 2 cosine of 2x all to the first power. Okay? So we derive the outside function of the purple thing. Now we need to derive this cosine of 2x. The outside function of that is just the cosine. So we multiply by minus sine, because that's the derivative of cosine. Copy paste the 2x, and that's that. Then finally, we're going to derive the inside bit of this, namely this 2x. That's just 2. And then we're done, because there's no more inside functions. So that's that. 5 functions composed. All you need to do is sequentially take derivatives as you move more and more inward, and be very careful about what you mean to derive. Okay? Yes, you can simplify this algebraically a little bit by combining some of these numbers that are being multiplied. I wouldn't bother. This problem was hard enough as it is, so leave it be. You did what the problem asked you to do. You derived it. Okay, so that's example number 5. Hopefully this is starting to click for you.